Okay, video 3, superposition and interference. So first of all, I want to just talk about superposition. And what that has to do is when two waves interact with each other. I'm going to show you a graphic in a second that's going to make a lot more sense. But basically, if two waves interact with each other, if there's a wave coming this way and a wave coming that way, and they meet, the component parts of the wave are added together. It's called superposition. I just love the word superposition, but let me show you this graphic. If I got this one big wave here and then a smaller wave that's going up, down, up, down, up, down, goes over this first big wave, then what you're going to see is the two waves are added together. That means that if this is, let's say, an amplitude of 0, this is an amplitude of 1, then that should be an amplitude of 1. Right here, let's say this is amplitude of 5, this is an amplitude of 1, this is an amplitude of 6. And let's say this is an amplitude of 4 and this is -1, then it drops right down to 3. I'm making up numbers clearly, but that's the idea of superposition. There's two really important examples of that, which I'm going to talk to you about in 3, 2, 1. Okay, let me show you a video embedded into me PowerPoint. So you're watching a YouTube video of constructive interference. Constructive interference is when I have two waves that meet and the peak of one wave meets the peak of the other. What will happen is I add these two peaks together, I get a very large peak, I get a very large trough. It amplifies the amplitude of the wave. Let me show you this video, hopefully it will work. We'll see. There we go. So this guy's got a similar kind of machine like I had, and he sends the two waves towards each other. But right now, boom, where they meet, the amplitude is much bigger than the two waves coming together. That is an example of constructive interference. I'm just going to pause this in 3, 2, 1. Okay, here we've got destructive interference, which is quite literally the opposite, where when we have two waves coming together, we're going to have the peak of one wave meets the trough of the other, the trough of that wave meets the peak of the other, and they literally cancel each other out. It's destructive. It's breaking it down, and it basically kills a wave. If not forever, at least for a brief second. We're going to talk more about this when we do sound in class. This video is a little bit longer, but let's just watch this one. Hopefully it'll work. Maybe. There we go. Look at this. He sent two waves where he's got the peak heading towards the right, the trough towards the left, and they meet right there. Boom, cancels out. And then the waves carry on past each other. Let me just, that was great. I love it. Let's do it again. And let's go back here. Right here, boom, they cancel each other out for that split second as the peak of one passes through the trough of the other. That is destructive interference. Let me pause this in 3, 2, 1. Okay, and this is the last slide for today. Why do we need to know about constructive, destructive interference or superposition? You just need to be able to predict what a wave will look like. And it's a classic AP question. I almost guarantee they'll ask you something on your AP test. Take this one, for example. I've got a wave going to the right, a wave going to the left. They would ask you to predict what it would look like as they pass through each other. So right here, it's making almost a sine wave. Right here, you can see when the waves are on top of each other, we can kind of start cutting away at it. And actually, they're kind of missing a point where they're actually going to be cancelled out completely, and they're moving away from each other. I clearly just changed the slide by accident. I am done. Thank you for watching. I hope you took good notes, and we will continue this accelerated tour through the wonderful world of waves in class on Tuesday tomorrow. All right, see you then. Have a good night.